Right, ladies, so far you've learned how to look at natural and industrial sources of sulfur dioxide and of oxides of nitrogen. You should be able to list a few of those, and you should be able to write the equations that go with those as chemical reactions that release sulfur dioxide and release the oxides of nitrogen, and that then go ahead to form acid rain. We've looked at evidence that these exist in the environment, and this section is more about the effects of acid rain. So that's where we're up to at this point. Sorry. Okay. When we were looking at last time, we were talking about Randwick having a very high sulfur dioxide level, and that in 2005 was because it was near Bunurong Power Station, which I think has since been closed down, but I'm not absolutely certain of that. And of course, the coal that is being burnt there, I think that's actually gone now. Chullora, again, was 0.23 because it was close to the Hume Highway and the M5. Well, I think there's been a bigger spread of traffic everywhere now because of different motorways, so these regions would only be indicative. Okay. Now, we've looked at the equations that are dealing with that, and we've talked about how to reduce the effects of sulfur dioxide by reducing the amounts of sulfur dioxide, by turning it directly into acid if we are smelting a metal, or by if it's going through a power station and the gas is going through the stacks, you can actually get the gas to react with calcium oxide in a neutralization reaction, which then forms calcium sulfide, and that you saw that being deposited. The catalytic converters are usually made of metals like rhodium and palladium, and they are fitted to motor vehicle exhaust pipes. And the nitrogen that was there is as nitrogen oxide, and the carbon monoxide, which we've already discussed as being poisonous. Both of those go through a reaction, and it converts it to the same form as nitrogen that's in the atmosphere already, and then carbon dioxide, which, although it will form acidic acid rain, is nowhere near as bad as the oxides of nitrogen are. Now, we've looked at the equations for those, and there's a general consensus that pH less than 5 is acidic rain, but that's not a hard and fast rule. That's just a guideline. And these are some of the equations that you might see related to that. Now, this is a forest that you see in, it's actually in Washington State, but it looks a lot like the forest in Germany used to look before they had to clean the atmosphere. Basically, these trees, if you go up to the top of these trees and start looking along these branches, you will actually find crystals of acid that burnt the tree. And that's why the forest has died there. Now, at this point, I've tried to embed the video for this one, but it won't allow me to for some reason. I'm not quite sure why. But I want you to take a minute, pause this, go back to your set of slides and look at this video, which is one of the best ones I've ever seen on just surmising what we've learned so far. And then the effects of acid rain are listed in this video, which are also extremely well said. So just take a minute, pause, and go ahead and look at that, and I'll talk about it again afterwards. So in the environment, when you were looking at this video, you would have found that the sulfates went actually up into the plant and caused the death of the plant, or caused it to become unwell, and that the acid in the soil was actually draining away things like aluminium and magnesium and calcium that the plant needs. It was leaching it out because it made it soluble suddenly, and aluminium became soluble and went up the plant and caused problems. So that, solubility of materials, some of them were absorbed by the plant and became worse, and some of them were forcing materials to be leached away in rainwater. Now, those are some of the effects on the environment. Other effects on the environment include fish that are unable to reproduce when the pH becomes too low. It affects their gills. It affects their uptake of calcium in their bones. When the pH in an aquatic environment becomes like that stream did, a very low pH, then what happens is the acidity means that the reaction is actually forced to release carbon dioxide back into the air through something called Le Chatelier's principle. And we'll be spending a fair bit of time on that. So we'll come back to this equation here. So in the watery environment, this acid breaks up into these two ions. When you get too much H plus coming in here from other sources, it forces it back that way to produce carbon dioxide, which is dissolved. And you'd think that would be good, but that actually forces it back this way, and the carbon dioxide becomes carbon dioxide in the atmosphere instead of in the water. And the result is there's actually less carbon dioxide in the water for photosynthesis to proceed. So we'll be talking about this again when we've dealt with Le Chatelier's principle, which is the next section. But there are also things that are problems for man-made structures. Man-made structures of limestone and marble are actually formed because marble and limestone are formed from the shells of marine organisms, which is mostly calcium carbonate. And when it gets compressed and turns into rock, it turns into limestone. And when it gets heated, it turns into marble. So we have all these things that are made of limestone and marble. And you get marble facades on buildings, and you've got marble statues and things like that. And they're both basically calcium carbonate. And the calcium carbonate, the calcium carbonate is an acid plus a carbonate. And that makes salt, water, and carbon dioxide. And so what you're actually doing to that is you're actually corroding away the part of the structure. And inside the bits that get dug out by the rain, you can often get bits of black soot, and it pits it and makes it discoloured as well. In addition to those structures, man-made structures that are made out of limestone and marble, whether they're buildings or statues, you've also got things that are made with large amounts of steel. Now, remember, steel is actually iron with a certain amount of carbon and other materials added to it. Now, an acid and a metal makes a salt and hydrogen gas. We know that rule. So that when we have a large amount of acid in there, things made of iron become a bit problematic. For instance, you've got bridges and boats that are all made of iron, and also the steel reinforcements inside inside concrete slabs are iron. And so if you start getting a reaction with those, they aren't going to hold the metal slabs together. Okay, so man-made structures as well as living things are also affected by acid rain. And we're going to be looking further into what happens with the acid rain. So when we started out this unit, we wanted to know about acid rain. We looked at oxides and different types of oxides, so you know what they were, including amphoteric oxides. You know which oxides on the periodic table are metal, non-metal, and amphoteric and neutral. And you know how we make man-made acid rain. and you know how that then